Welcome back, everyone. Today, we're diving into the wild world of AI code generation. It's a field that is just exploding with potential, but as we'll see, it's also packed with some pretty serious risks.
That's right. We're going to trace the entire journey of an AI coder, drawing on some fascinating new research. We'll look at how these AIs are being trained for super specialized jobs, but also how they can be tricked, and, maybe most surprisingly, why they can be so unstable.
So here's what we've got lined up. We'll start by pushing the limits, seeing how AI learns obscure languages. Then we'll see how it can be a co-pilot for beginners. After that, we dive into the darker stuff, jailbreaking and data leaks. And we'll wrap up by trying to understand how these models actually think and why a little human emotion can throw them for a loop. Okay, so first up, let's talk about pushing these models to their absolute limit. We all know large language models are amazing at common stuff like Python. But researchers asked, what about the really niche, really specific languages? Think about the code that runs semiconductor factories. That's where these powerful AIs usually just give up.
And you can see why right here. I mean, look at the difference. On the left, you've got Python, it's clean, it's readable, and there are billions of lines of it online for an AI to learn from. On the right, that's ALPG. It's for controlling hardware, it looks like gibberish, and there's almost no public data to train on. It's a totally different beast.
So how on earth do you teach an AI a language that barely has any textbooks, especially compared to the massive libraries we have for Python?
Well, they came up with this really clever framework that basically mimics how a person would learn. First, they have an LLM sort the existing examples from easy to hard. Then, the main AI studies them in that order. It starts with the basics and slowly builds up its knowledge. Only then, once it has that foundation, does it try to generate the really complex code. And you know what? It worked. It worked really well. This chart shows how often the AI-generated code was a perfect, exact match. Their new method, PKE, was over 15% more accurate than the next best approach. It turns out, teaching an AI how to learn is a total game changer in these specialized fields. Okay, so we've established that an AI can become a brilliant coder in even the most obscure languages. But that brings up a huge question. Just because the tool is smart, does that mean a total beginner can use it safely? Especially for something really critical, like protecting user data? You've hit on the exact problem. In a study, researchers had both data privacy experts and complete novices use ChatGPT for the same task. The experts, who knew what to ask and what to look for, were able to guide the AI to a secure solution. The novices? They failed. Every single time. A 0% success rate, which is, frankly, a crisis for usability. Well, 0% is really bad. It shows just how wide that gap is. So what did the researchers propose to fix this? How do you help the novices? They created a fantastic little tool called the DPCheatSheet. The first part of it is something called worked examples. It doesn't just show you the final code. It shows you the entire step-by-step process an expert took, the prompts they used, the questions they asked. It teaches you the workflow so you don't just blindly trust the AI.
The second part is just as important. It shows you erroneous examples. These are common mistakes that LLMs tend to make on this specific task. It shows you the bad code, explains why it's bad, and then shows you how to fix it. So you're not just learning from success, you're learning from failure too.
That makes so much sense. So did it actually make a difference? How much better were the beginners who used the cheat sheet?
The difference was night and day. The group with a normal tutorial only spotted about 15% of the mistakes in the code they were given. But the group with the DP cheat sheet, they identified almost 67% of the errors. It made them more than 4 times better at spotting critical security flaws.
All right, so we've seen AI learn new things and even help people learn. But obviously, that same power can be twisted for malicious purposes. What happens when someone intentionally tries to get an AI to write something dangerous, like a piece of malware? This is where we get into the dark side. Researchers are studying something called jailbreaking, which is basically tricking an LLM to get around its built-in safety rules. And as they point out here, the very thing that makes these AIs so good at generating helpful code is what makes them a potential weapon for cyber attacks. And they found a really sneaky way to do it. It's a 2-step attack. First, they use a dumber, less safe AI to generate a very basic, rough draft of some malware. Then, they take that messy code and give it to a much smarter, safer AI. But they don't ask it to write malware. They just say, hey, can you improve and refine this code for me? And the powerful AI, just trying to be helpful, polishes the malware into a finished product. That is clever, but is something like that actually feasible in the real world? What does it cost to pull off an attack like that? You're not going to believe this. They calculated the average cost for each successful attempt at creating malware this way. It was 7.5 cents. And it is terrifyingly effective. Look at this chart. If you just ask a powerful AI directly for malware, you've got about a 7% chance of success. But using their two-step refinement trick, the success rate jumps to over 60%. It's a huge, gaping vulnerability. Okay, jailbreaking is an external threat, but what about dangers from within? These models are trained on a sea of public data. What if they memorize something sensitive during training and then just spit it out later? That's a massive concern, and it's called verbatim memorization. When an AI trains on code from places like GitHub, it can accidentally memorize things people left in their code, passwords, private API keys, email addresses. Then months later, it might just suggest that exact secret key to a random user. It's like a ghost in the machine.
Yikes! So once that sensitive data is baked into the model's brain, is it there forever? Can you actually force an AI to forget something? You can't. The brute force way is to completely retrain the model from scratch, which is incredibly slow and expensive. But the new research is focused on something much cooler, machine unlearning. Think of it less like wiping the whole hard drive and more like performing delicate targeted surgery to remove a specific toxic memory.
And their technique, which they call code eraser, is shockingly effective. Look at this table. Before the unlearning process, one model could recall a specific piece of sensitive code with over 99% accuracy. After code eraser, that dropped to below 16%. We can essentially perform targeted digital brain surgery on these AIs now. This is all so cool, but everything we've talked about so far, good and bad, has focused on the AI's final output, the code it produces. To really trust these things, don't we need to understand the process? We need to pop the hood and see how it's actually thinking. We got to crack open that black box. You're absolutely right, and some brand new research is finally giving us a peek inside. Scientists are now studying AIs that are designed to output their reasoning traces, basically showing their work and explaining their thought process step by step before they even write the code. And by studying thousands of these thought processes, they found a clear, four-phase pattern that the AI follows. And what's wild is how much it looks like a good human software developer's workflow. It starts by gathering requirements, then it brainstorms solutions, then it implements the code, and finally it reflects on its work to find any errors. That's incredible. Can we actually see what one of those reasoning traces looks like in plain English? For sure. This right here is an actual quote from an AI's internal monologue. Look at how it's breaking down the problem. It sees the function name, it recognizes that the word self means it's part of a class, and it correctly interprets the instructions from the documentation. It's logically deconstructing the request just like a person would, before a single line of code is written. All right, so for our last section, we need to talk about a really subtle, but maybe one of the most important problems. Let's say we have a super smart AI, we can see its thought process, and we've made it secure. But how reliable is it? How does it handle the messy, emotional, and often imprecise way that real humans talk? Exactly. So here's a perfectly logical, clear, and neutral request. You can't get much more straightforward than this. And then here's the exact same technical request, but now it's wrapped in all this human emotion and stress. The core task, sort a list, hasn't changed one bit. So this gets to the core of it, right? Should this logical machine give you a different answer just because you sound stressed out? You would think the answer is no, but the research shows it often does. And this is the key finding. A model's performance has absolutely zero significant correlation with its stability. In other words, just because an AI is great at coding challenges doesn't mean it's reliable. You can have a top-performing model that completely falls apart if you change the tone of your prompt. Performance is not stability.
So even our best and brightest AIs can be incredibly brittle. That's a pretty sobering thought to end on after this whole journey.
It really is. We've gone from teaching them complex new skills to helping people use them better, to defending against attacks and even looking inside their minds, only to find that they can be tripped up by something as simple as human tone. It all comes down to trust and reliability. Which really brings us to the most important takeaway of all. This isn't just about building more powerful AI. It's about us, the humans, building better skills and better tools to work with them. Because as AI gets better and better at writing our code, the real challenge for us becomes, how do we get better at questioning its answers? That's all we have for today. Thanks so much for joining us on this deep dive.
Thanks for watching, everyone. We'll see you next time.